All right, guys, so today we're going to be talking about key features in graphing quadratic functions. So we're going to be identifying what the key features are and then using those to create a graph. So we're not using the book really for this lesson, so we're just going to use a note sheet that I posted along with this video in Google Classroom. And then if you need a calculator, you can use a calculator also. So I pulled out this page in your book just because it goes over how to find the key features for each part. So this is from page 200. But if we have a quadratic equation looks like this, okay, where we have an x squared term, an x, and then a constant. So in order to identify the key parts, here's what they all are. We have a vertex, the y-intercept, the x-intercept, and the axis of symmetry. Now when we do these, your axis of symmetry and your vertex actually go together. So usually I find those two things first, because the axis of symmetry does have to pass through the vertex. But in order to kind of set up the equation, we have this quadratic function, and a standard form for quadratic functions look like this. So it's ax squared plus a bx plus c. So when you hear them talking about a, b, and c terms, that's where they're getting them from. So the a is always the coefficient from the x squared, the b is always the coefficient from the x, and the c is always the constant, okay? All right, so the key parts here and how to find them, the first is the vertex. And to find the vertex, we use this formula. It's the opposite of the b term over 2 times the a term. So if we think of it like, so here's again your a, b, and c, we would take the opposite of the b term. So since this is -9, we would use a +9. And then it's 2 times the a term. So 2 times 2 is 4. So that means that is where our vertex would be. Okay, that's the x value of the vertex. So the vertex is always going to be a point. So the -b over 2a tells you the x value of the vertex. And that is actually the same way that we find the axis of symmetry. It uses the same equation. So over here. Okay. So that's why I said when we do the axis of symmetry, we kind of do the vertex with it. Okay, so if you have the x value of the vertex, the way we find the y value is we just plug it into the original equation. So you would substitute that in for x, and that'll spit out the y value for you. So that's what they're saying here. So that's how they got that point. So the vertex, remember, is the highest or lowest point on a parabola. So if we have a parabola, your vertex is that highest or lowest point. Okay? And your axis of symmetry would pass through that because your axis of symmetry is what cuts the graph in half. So that's what we have here. And that's why the axis of symmetry and the vertex will always go together, because they go through one another. The y-intercept is always the easiest one to get, because the y-intercept is what happens when we plug in 0 for x. So the y-intercept is actually always just going to be the constant term. Because if I plug in 0 to my equation, it's going to become 0 minus 0 plus 4. So the y-intercept is always the easiest one to get. The x-intercepts are probably the hardest ones to get because you have to actually solve this equation in order to find the x-intercepts. But we don't actually use those too much when we're actually solving. So once we have all the key parts, we plot everything, and that's what helps us get that parabola shape, that U shape to the graph. The other thing that I want to point out really quick is how a graph will open. It's either going to open up or down. So in this case, this graph, if it's opening up like a cup, that means the arrows are facing up in both directions. If it opens down like a frown, that's what it's going to look like. Okay? So we can tell if something's going to open up or down based on the a value, that first leading coefficient. If that leading coefficient is positive, it's going to open up. If that leading coefficient is negative, it opens down. Okay. So on the next slide here, I just have a couple of examples. We're just going to graph it. So I know this kind of has a lot of information on it, but I'm just going to go through a couple of graphs and you'll understand what I'm talking about. So here's a quadratic equation, x squared plus 4x plus 1. So right away, I always put how it opens, either up or down, because I can get that just by looking at the equation. Again, that comes from the beginning of the function. What's in front of the x squared? If it's positive, it opens up. If you see a negative, it's going to open down. So in this case, since it's just a plain x squared, there's no negative there, I know this parabola is going to open up. Okay. The next thing I find is the axis of symmetry and the vertex. Those are going to go together. So the way we find those two things is we use that formula. So maybe I'll just put that up here. Axis symmetry slash the vertex. Pen is giving me some problems. Axis of symmetry slash the vertex. Okay, we get that from using that equation, the opposite of b over 2a. So remember, your a term is what's in front of the x squared. Your b term is in the middle. Your c is your constant. So if I have to take the opposite of my b term, that means I'm going to take the opposite of positive 4, which is negative 4, over 2 times my a term. Now, technically, that a is a little imaginary 1 in front, so it'd be 2 times 1. So we get this. So negative 4 over 2 gives me an axis of symmetry at negative 2. So we have x equals negative 2. So if we have the axis of symmetry, that means we know half of our vertex. We know the x value of the vertex. So in order to get the y value of the vertex, we just plug in negative 2 everywhere we have an x in the function. So let me just do that here on the side. So that means we'd plug in negative 2 for x. So that's negative 2 squared plus 4 times negative 2 plus 1. And then we'd have to do the order of operations for that if we were doing it by hand. But let me show you really quick how to type that in your calculator. I would literally just type it in exactly as I wrote it. So negative 2 squared plus 4 times negative 2 plus 1. So if you use a calculator, it'll make your life a lot easier. It'll do all the order of operations for you. And that spits out our y value at negative 3. So that's our y value of our vertex. So I'm going to plot these two things right now. So our axis of symmetry, that is a line that cuts the parabola in half. So if I graph him, do that first. So we need our x symmetry at x equals negative 2. So at negative 2, we have this vertical line. Make it a little thicker here. Okay. My vertex has to be on that line because the axis of symmetry must pass through the vertex. So at negative 2, negative 3, there's my vertex. Okay, the next thing we're going to find is the y-intercept. And this is probably the easiest part of this whole thing because the y-intercept is what happens when we plug in 0 for x. Well, if I plug in 0 for x, it's going to be 0 squared plus 4 times 0 plus 1. So your y-intercept, just as a little hint here, it's always your constant term. My constant term here is 1. So I plot that y-intercept. So here's how I get the third point to get that U shape. Instead of using the x-intercepts, because sometimes those are hard to find, all I'm going to do is reflect this point over the axis of symmetry. Because in a parabola, the axis of symmetry cuts it in half. So if I have a point at that red spot, I need to have a point in the exact same spot on the other side. So just count your distance. If this point is 1, 2 for my axis of symmetry, I'm going to go 1, 2 in the opposite direction. So if you know your y-intercept, we reflect that point over the axis of symmetry, and now I have my parabola. I'm just going to connect the dots, giving it a nice smooth curve, and there's our parabola. Now we just have to talk about, is our point a minimum or a maximum? So remember, minimum or maximum means what is your vertex, basically? Is your vertex the lowest point on the graph, or is it the highest point on the graph? So in this case, we have a minimum. That vertex is the lowest point this graph will go. Okay? All right, let's do another one. The more we practice this, the better we're going to get at it. So here's another equation, negative 2x squared plus 8x minus 5. So right away, I see that negative. That's telling me that this graph is going to open down. So when I plot all my points, I'm going to make sure it actually does that. So if I know I did it right. Okay, next we're going to do the axis of symmetry and the vertex. Those go together. So we're going to just kind of work it as one thing at this point. So we use that equation. It's the opposite of the b over 2a. So in this case, my b term, remember this is a, b, c. My b term is 8, so we'll take the opposite of 8 over 2 times the a term. So 2 times negative 2. So that gives me negative 8 over negative 4 which ends up being 2. So if I know my axis of symmetry, I know half of my vertex. I know the x value of the vertex. So now I just have to find the y value. So I take that value that I just got and I plug it in for x everywhere in the equation. So that'd be negative 2 times 2 squared plus 8 times 2 minus 5. And again, if I don't want to do all that work by hand, I'm going to use my calculator. So I type it in exactly as I wrote it with the parentheses and everything. So negative 2 times 2 squared plus 8 times 2 minus 5. And let my calculator do all the work. Look at that. It gave me a 3. So that tells me that's the y value of my vertex, 3. So let's kind of put these two things in, and then we can get the y-intercept and reflect it. Okay, so my axis symmetry is at positive 2. Draw that in a little straighter, positive 2. There's my axis of symmetry. Maybe I'll label it here, AOS. And then I plot my vertex, which is at 2, 3. Remember, your vertex has to go on the axis of symmetry. So if it doesn't, you did something weird. Okay? The y-intercept we get by looking at our constant term. So the y-intercept here is at 0, negative 5. So I plot that 1, 2, 3, 4, 5. In order to get my third point, I'm just going to reflect it over the axis of symmetry. It has to be symmetrical on both sides. So if this is 1, 2 for my axis of symmetry, I'm going to go 1, 2 over on the other side. I'm just going to label this really quick, just in case you need it. Keep moving the graph on accident. So once you have those 3 points, now you can make that curve to the graph. So there's my points. Didn't do it so smooth, but that's okay. So now if I look at this picture, my parabola is opening down just like I said it should. So that's how you can kind of check if you did something right. All right. I'm just going to go through one more. I'm going to do this one a little quicker, and then that's about the end of our notes for today. So look at the leading coefficient. That should tell you if your graph opens up or down. So that's a positive 1/2. So that tells me this graph is going to open up. Okay. Next, we're going to get our axis of symmetry and our vertex. They go together, so we do them together. And that's why we use the opposite of B over 2A. Just remember, we have A, B, C. So the opposite of B would be the opposite of positive 2, which is negative 2 over 2 times 1/2. So negative 2, 2 times 1/2 is 1. So that's just going to be x equals negative 2. Negative 2 over 1 is just negative 2. So let's maybe draw that in now. So negative 2. There's that nice straight line. All right, so if I found my axis symmetry, that means I found half the vertex. So I know my x value of my vertex is going to be at negative 2. I just need now to find the y value. So again, we set it up by taking 1/2. We're going to have negative 2 squared plus 2 times negative 2, and then minus 6. So again, I don't want to do that by hand. I'm going to use my calculator. And instead of 1/2, I'm just going to put in 0.5 just so I can type it in a little quicker. So let your calculator do all the work for you. If you type it in correctly, again, exactly as you write it, it should work out for you. So if I do that, I get negative 8. So let's plot that. Negative 2, negative 8. There's my vertex. Okay. Last thing we're going to do then is find our y-intercept, which again is always going to be the constant term. So that's negative 6. 5, 6. There's my y-intercept. So to get my third point, I'm just going to flip this or reflect it over the axis of symmetry. going to be the exact same distance on the other side. So there is our parabola. If I connect the dots, I have my nice U shape. It's opening up like we said it would, so we know we did it right. Okay, so if I look at this, my vertex there is a low point, so we would call that a minimum. I think I forgot to do that on the last one, so let's go back really quick. So in this one where my vertex is the highest point on the graph, that's an example of when you have a maximum. Okay. So in order to find all the key parts, the most work you're going to do is with the vertex and the axis of symmetry, and that's using that same equation every time. The opposite of b over 2a. The rest of it we get a lot from just inferring from the equation. So making sure you can read the equation, where I got all those numbers from, and then making sure you can put everything in the graph and kind of use that to draw the picture. Okay.